All right, now I want to get a sneak peek to our next generation deep learning solution called DeepWater. And just a few things. So first, DeepWater is one interface, provides the ease of H2O. It provides GPU capabilities and significant performance gain. So under this framework, we're combining the best of some of the most popular and performant deep learning frameworks out there, including TensorFlow, Caffe, and MXNet. This opens up the possibilities to build sophisticated neural networks that can solve tremendous problems for image, video, and speech recognition use cases, natural language processing use cases, advanced networks such as convolutional neural networks and recurrent neural networks. In addition, being able to leverage GPUs is very huge in that GPUs can be 100 times faster for problems like image recognition. So what I have here, actually before I do that, so what I'm going to do is I'm going to spin up H2O on, or I have spun up an H2O instance on a GPU cluster, and I'm going to do an image classification exercise. I'm going to determine whether a picture is a cat, dog, or mouse. Here are some snapshots from the Flow interface with DeepWater. So we have the backends, MXNet, Caffe, and TensorFlow, and a lot of the network architectures, popular network architectures that have been very successful in image classification competitions available. Now, just because we have these network architectures built in, we do not prohibit users from entering their own network architectures or describing their own architectures to their heart's content. It can be as complex as possible, and it's not a problem. So quickly, this is my instance on Amazon, which I have on a GPU instance. I can validate this very quickly. What I have here, so let me SSH into this machine, and I can validate that there is GPU here. So I have an NVIDIA driver which says that I have a GPU, and I need to make sure that H2O is running on this. If it's not, I can quickly start. So it is running. Perfect. So I have H2O running. I can refresh to make sure that this is correct. Perfect. And I've already preloaded some data, which just to speed things up. So I have a data frame called cat, dog, mouse. And essentially what this data is, I can view the data, it's very simple. And you don't want to make the data frame too big with images. Instead, you essentially have one of the columns represent the pointer to the image. So really I have one column that represents where you can find the image of cat, dog, and mouse, and then whether it's a cat, dog, and mouse. So you have a label called cat, dog, and mouse, and then from here I can basically build a model. So I can go, and now in this new version of H2O, which is currently experimental, I can type in DeepWater. I can type DeepWater, cat, dog, mouse, pick my training frame, target being the label, and I'm going to put a fair number of epochs so we can actually see this running. Pick a basic architecture called Lanet. Notice that by default it's GPU enabled. I can build this model, I can view it, and you can see in real time the training of this model. Now this is very useful. I didn't show this before, but all the models can do this. You can actually see how the training is progressing as the model is being built. This is very important because if it's not going well, you can instantly stop the training of the model, prevent yourself from wasting time and checking if you have anything wrong. This can be done not only in Flow, but in Python and R. You can launch a job in R and Python. You can use Flow then to monitor the progress of the job. If you don't like it, you can stop it. I've specified only 300 epochs, so I know that it's done. And in this case, I have some pretty good error rates at around 10%, cat, dog, and mouse. And this is a typical output that I have. I can obviously do prediction on this, pick my cat, dog, and mouse, do predict. Prediction is done. I can combine the prediction frame. View the frame. View the data. And you can see where it made a mistake. So here, where it was a cat, you thought that was a mouse. We can go back. Here I'm monitoring some of the memory usage, so I'm using some of the memory in the GPU. So that's a quick look at DeepWater, where we demonstrate integration. In that case, I actually used MXNet in the backend, so integration with the MXNet platform, simple image classification for cat, dog, and mouse. Images, I can show you quickly what those images look like. So here on my local machine, I have local copies of those images. So that model went through all these images, processed them, and the neural network learned whether it was a cat, dog, and mouse. So those are dogs. I can go to cat real easily and see some of the cat videos, photos. This is just to show you some sampling of the images that trained on.